If you've ever driven a car before, have you ever noticed that little arrow that rotates between numbers on your dashboard? I mean, I sure hope you do. It's called a speedometer, and it's supposed to show the speed that you're going at right now. Now, have you ever been tempted to slam on the gas just to see how far that arrow will go? What if you had infinite gas? How fast could you go? I mean, realistically, if you just keep accelerating, you would eventually go infinitely fast, right? Right? I'm sorry to break it to you, but physics isn't that nice. So what is the fastest that anything can go? Welcome to light speed. The point where reality stops making sense and I start procrastinating the script. First of all, what is light speed? Currently, the speed of light is 299,792,458 meters per second. How did scientists measure something that fast? Well, it's a lot more complicated than you might think. To measure the speed of light, you need two synchronized clocks that measure the time it takes from one clock to the next. Put distance over time and you get your speed of light. The question is, how do you make sure your clocks are synchronized? Well, to send a signal from one clock to the next, the signal will go the speed of light, which we don't know. What if we have a clock midway between the two clocks that sends a signal at the same time so that signal syncs up the two clocks? Well, relativity will distort the time of the signal, and relativity is dependent on the speed of light, which we don't know. It turns out that the only way to measure the speed of light is through a mirror bouncing the light back. This means that the one-way speed of light has never been measured, and there is currently no way to prove that the speed of light is the same in all directions. The speed of light, for all intents and purposes, we assume is the same in all directions. But that's just the beginning of the weirdness of the speed of light. Everybody has heard that the speed of light is the maximum speed you can reach. But why is that? There are two things you have to know first. First was first theorized by Galileo that all motion is relative, and more specifically, cannot be detected without a reference to an outside point. If you are in a plane blindfolded, for instance, how do you know if you're moving or not? This is the principle of relativity, and it has lasted for hundreds of years. The next is that the speed of light is constant. At least the two-way speed of light is. To understand how time works in tandem with speed, first imagine a rocket going at light speed and you inside the rocket. with a mirror. For you to see yourself in the mirror, the light would need to not only move at light speed from your eyes to the mirror, but also additionally the rocket ship, which would be going at light speed, which would violate the constant speed of light, which then dictates that you would not be able to see yourself in the mirror, as light could not ever reach any place. And by extension, not only will the mirror not be seen, but everything in front of you would be pitch black. If you realize that you can't see anything, you would be able to determine that you were moving at light speed, which would violate our first law of relativity. So, what is going on here? Since neither of these outcomes are possible, it is reasonable to assume that a universe where light speed is possible does not exist. So, what is going on here? What is physically stopping us? The most intuitive explanation I could find is that the subatomic particles cannot move faster than light. So, if a proton in your body is going at light speed, then the electron orbiting it will have to go faster than light, which is impossible while orbiting it. Similar things happen near the speed of light, where if the proton is going right under the speed of light, the electron will need to physically slow down to maintain continuity. And when every electron in your body slows down, your brain, aging, chemical reactions, everything slows down. This is just the beginning of why the speed of light is crazy, but this is all that I have to show you.